Now let's look at an example of a box plot with specifically how to draw a box plot. So I have puzzle one right here that says we're looking at a distribution table for the scores on an exam for a large upper level statistics class. And the right hand column shows the percentage of scores in each interval. And then it tells us this information that the lowest score was 0, the second lowest score was 6, and the highest score was 100. So to draw a box plot of this data, you'd have to find the median, Q1, and Q3. And you'll notice that this is a little different than what we're used to. Usually we have an actual data set with numbers. And we would be calculating Q1, Q2, and Q3 through the methods that we've seen for box plots. However, here we have this distribution table. And we do know that Q1, Q2, and Q3 are percentiles. So I think we can use these percentages to go ahead and find them. So first of all, it says to find the median. And we know that the median is the 50th percentile. So if I look at this table, it says that 25% of the students scored between a 0 and 50 on this exam. So right at 50, there is 25% of the data to the left. That is actually our Q1. I'm going to go ahead and write that down. That is our 25th percentile because there's 25% of the data below 50. So that's not the median. Median is the 50th percentile. So if I keep going on this table, right at 60, I have 10 plus 25, I have 35% of the data to the left. So again, that's the 35th percentile. That's not the 50th percentile. If I get here to 70, right at 70, I have 15 plus 10 plus 25. That gives me that 50th percentile. So 70 is the median or the 50th percentile. And then if I keep going right at 80, I have 25 plus 50. So that's the 75th percentile. So Q3 is going to be 80. So instead of calculating these from the exact data that we would be given, we're looking at these percentages and using what we know about quartiles and percentiles to figure out these numbers. So the middle 50% of the scores, that's our IQR, always lies between Q1 and Q3, right? The 75th percentile and the 25th percentile. So I can just go ahead and fill in Q1 is 50 and Q3 is 80. So these three statistics give me my box. If I wanted to draw a box plot, I could go ahead and draw the box part of the box plot with those. The next part says to list all of the outliers because I definitely need to know if the data set has outliers. So I know if I'm going to be drawing dots on my plot for those. And so I know where to draw my whiskers. So wait, we have these formulas to kind of check if there are outliers in the data set, right?
Yeah.
So low outliers are any numbers less than Q1 minus 1.5 times the IQR. So Q1 in this case we know is 50 minus 1.5 times our IQR is always going to be our interquartile range, which is Q3 minus Q1, which is in this case 80 minus 50, which is 30. So Wade, if you can use Python as a calculator, what do I get for my bound for the low outliers?
The low outlier bound is 5.
5. So that means that any number on our list that is less than 5 is considered a low outlier. And if I look at this table, I don't know how many numbers are less than 5, right? Because I just know that 25% of the data is between 0 and 50, but I don't actually know how many of those numbers are less than 5.
I feel like you said earlier you knew the lowest 2 people. Did I remember that?
This problem did actually give us, I underlined it. It said the lowest score was 0. Okay, well, that's definitely going to be an outlier. The second lowest score was 6. So that does tell us, okay, there's one low outlier and it's right at 0. Let's check for high outliers. So high outliers are any numbers that are bigger than Q3 plus 1.5 times the IQR. So my third quartile is 80 plus 1.5 times 30. And Wade, what do I get for that?
The range is going to cap out at 125.
125. So if I had high outliers in this data set, I'd have scores above 125, which for exams doesn't really make sense.
It's a really good score.
That's a great score, a lot of extra credit. But this exam only went up to 100. So I actually have, I'm going to say no high outliers. And this is all that I need to know to draw my box plot. So let's go ahead and draw it just really quickly, even though we can use Python to do this, and that might be a little less time consuming.
Though it'd be really hard because Python really needs data. So when you just have descriptive statistics like you have here, I would have to like kind of fake a data set that matches those descriptive
Yeah,
statistics.
that would be incredibly obnoxious. So
Yeah, this would be really a good time to draw the box plot.
So let's go ahead and do it. So I am going to mark my outlier first. I always like to do that. So I am going to say that 0 is just this bottom line. So I can put it anywhere in this plot. So I'm going to draw a little dot right at 0. And then I'm going to go ahead and label this y-axis in terms of tens, since this exam goes from 0 to 100. And then after I draw my outliers, I always like to go ahead and do the box. So the Q1, Q2, and Q3. And we had Q1 actually as 50. So I'm going to draw a line right at 50 for my Q1. My Q2 was 70 for my median, and then Q3 was 80. And here is my box for my box plot. The last part is that I want to go ahead and draw my whiskers. And it says right here, it says if the data set has no outliers, the ends of the whiskers represent the min and max. So for the high outliers, we didn't have any. So I can draw my top whisker all the way up to 100 to represent my maximum value. And then my bottom whisker, I did have a low outlier. So it says if the data set does have outliers, the outliers are plotted as single dots, which we did. And the ends of the whiskers represent the highest and lowest data points that are not outliers. So if I go back to the problem, it said the lowest score was 0, and that's an outlier. And then the next lowest score was 6. So that's our first lowest score that's not an outlier. So I'm going to draw my bottom whisker down to 6. And there I have a nice looking box plot. And this was a vertical box plot, but I could have drawn this as a horizontal box plot if I wanted to. But the vertical looks good for now.
I was surprised you went with vertical. It's your favorite horizontal.
I know, right? So we have one more example.
There you go, the horizontal box plot.
With a horizontal box plot that I want to go through really quick. So it says to answer the following questions about the horizontal box plot. And before I even answer the questions, I'm just going to really quick label what I know. So wait, looking at this box plot, do you see any outliers?
I see no dots whatsoever. So I assume that means there's no outliers?
No outliers on this box plot, which makes it really nice. That means the bottom whisker is going to be our minimum value. The top whisker is going to be our maximum value. And then the box represents Q1 for the bottom part of the box. Q2 is always the line inside the box. And then Q3 is the top part of the box. So question A actually says, what is the value of Q3? It looks like it's right at 11. The median is Q2 for part B, so that is right at 7. And then here's where the questions get a little bit more complicated. C says, what percent of the data is less than 4? So 4 is actually, if I look up here, Q1. And we know that Q1 is the 25th percentile. So by definition, that means that there is 25% of the data less than 4. So this answer is just going to be 25%. Thinking more about percentiles, I know that between Q1 and Q2, that's the 25th percentile and the 50th percentile, that this is also 25%. Between Q2 and Q3 is also 25%, because that's the percentage between the 50th percentile and the 75th percentile. And then above Q3 is also 25%. So this box plot is kind of divided into quartiles, into 25%.
And for the longest time, I didn't find this very intuitive, because look at those areas. That last 25% is so tiny, but you're saying a quarter of all the data is in that tiny range?
Exactly. So one thing that is kind of, you have to get your mind to think a different way about the box plot, is that areas don't actually matter. What matters is these values for the quartiles and the percentiles. And the fact that we know that 25% of the data is less than Q1 and 25% of the data is greater than Q3, even though these whiskers, if we think about like the length of them, they're actually different lengths. So that's a great point. D says, which interval has a greater percentage of data? 4 to 7. So this interval right here, or 7 to 11, that kind of talks about Wade's point that they have different areas, but the percentage of data in those intervals are actually the same. They're both 25%. So we got to get areas out of our mind for this.
And really, that's the only type of visualization where area really doesn't matter. It's a unique aspect of a box plot that doesn't really appear in a lot of the visualizations I work on.
That is so true. E says, what is the range of the data represented in the box plot? And the range we said is just the max minus the min. So I have my maximum value looks like it's 12. My minimum value is 2. So the range is 10. And one thing I want to say about the range is if this data did have outliers, we would want to include those outliers as either the min or the max. Like say I had a low outlier here at 0, then my range would actually be 12 minus 0. Because even though 0 is an outlier, it still is technically the minimum value. It still is part of the data set. So the outliers are a part of the data set. So they are included in the calculation of the range. Last question, Wade already answered. Are there any outliers in the box plot above? I'm going to go ahead and say no because I see no dots. So that is how you read a simple box plot like this. And hopefully as you create box plots in Python, now you know how to read them.